Hi everyone, Ian here from Crack Maths and welcome to this tutorial video on square and cube numbers designed for anybody taking Foundation GCSE. This video is for you. Okay, so in this topic, square and cube numbers, we're going to eventually be looking at answering questions like these four that you see here on the board. So if you want to have a quick pause and have a look at these, if these are questions that you're already happy with, then brilliant, you can move on to another video. If not, stick with me and we will work through them together. Okay, so let us get first of all started on the concept of square numbers. So square numbers are numbers that we get when we multiply a number by itself. Okay, so say for example, I had a number like this, 3, and I had a little 2 here. We refer to this number as being 3 squared. Now, 3 squared gives us 3 times 3, and that gives us 9. Okay, now the reason why they're called square numbers is because if I had a square here, let's make it a 3 by 3 square, like this, where this length is 3, and obviously this length is 3 because with a square, all the lengths are the same size. Well, when we have the length 3 and we square it, when we turn the length 3 into a square, we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. So 9 here is what we call the square number. Okay, so this here is the square number. And this here, this 3 over here, is the square root. Okay. Okay, now square numbers are only made by squaring whole numbers, okay, or we could say integers. Okay, the square number always comes from squaring an integer. So integer is a word that we use and it just means whole number. Okay, so let's have a look at the integers that we square and the square numbers that we get. Okay, so let me delete all this here. I'm going to have here the integers. Okay, I'm just going to use this word a lot to try and help you grasp it. I remember actually being a kid and be like, what is an integer? But yeah, an integer is just a name in maths for a whole number. Okay, right, so we've got the integers here. And then we're going to have the square numbers. Okay, now the square numbers have to come from an integer. This is a question that we sometimes get asked. Sometimes, why isn't this a square number? Why isn't this a square number? And it's because it isn't the result of squaring an integer. Okay, so square numbers. Okay, so say if I've got an integer, my first integer is 1. Well, the square number is going to give us 1 as well, actually, because 1 times 1 is 1. If I've got another integer here, the next integer is 2. Okay, then the square number that links to 2 is 4. Okay, and this has come from, in fact, I put this in brackets here, 1 times 1 for the first one, 2 times 2 for the second one. Okay, the third square number, okay, comes from 3. Okay, and we could say that this is going to be 9, and this has come from 3 times 3. Okay, so the square numbers currently that we have are 1, 4, and 9. Okay, now these integers that we've got here, these are the roots of the square number. So if our square number is 1, its square root is 1. If our square number is 4, its square root is 2. Okay, you might remember this from the last video. We talked about square roots actually. So if the square number is 9, the square root is 3. But the things that we have to really remember is we need to remember our square numbers. Okay, now we don't have to remember all the square numbers. We just have to remember them up to a certain point, which is 12 squared. So I'm going to continue with this to get all of those. So here we've got 4, and that gives us 16. So that's from 4 times 4. Then we have Here from 5 we've got 25, and remember that's by doing 5 times 5. Then here we're going to have 6, okay, and that's going to give us 36, and that's from 6 times 6. Then we've got 7, okay, which gives us 49 from 7 times 7, okay, and then we've got 8, which gives us 64 from 8 times 8, okay, and then I'm running out of paper there actually, so what I'm actually going to do is I'm going to rewrite these now in a different way, and then I'm going to continue them because I think we've got the idea of how these are created, how the square numbers are created, so we can actually just write them in a list. So let me now just delete all of this here. Okay, I'll delete that there. I'll delete this here. And then let's try just writing our square numbers in a list. So we have got 1, okay, then we've got 4, then we have 9. So remember, I'm just thinking here, 1 times 1, 2 times 2. In fact, we've got 3 times 3, then we've got 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, and then 12 times 12 is 144. Okay, so these are all of the square numbers that we need to know, but you can always rely on your ability to work them out by just multiplying the numbers by themselves. Okay, so what I want to quickly do here is just to really emphasize the connection between square numbers and square roots. I'm just going to go through these as well. So the square root of 1 equals 1. The square root of 4 equals 2. The square root of 9 equals 3. We've got the square root of 16 equals 4. The square root of 25 equals 5. The square root of 36 equals 6. The square root of 49 equals 7. The square root of 64 equals 8. The square root of 81 equals 9. The square root of 100 equals 10. The square root of 121 equals 11. And the square root of 144 equals 12. Okay, so I'm going to highlight these things again inside the roots, just to remember that these numbers here that I'm highlighting are the square numbers, and the answer to the square root of these numbers is the root. Okay, so the blue numbers are the square numbers. Okay, in fact, let me highlight that in blue. And then if I go through these numbers here, these pink numbers here, these are the roots. So these are the square roots. They are the numbers that when we square them, so I'm really going over this. These are the numbers that when we square them, give us the square number. Okay, so let me write this down. These here are square roots. Okie dokie. Right, now what I would suggest is if you pause this video here and you get something to write these down with, so you can write yourself your list of square numbers and your list of square roots, or if you're really confident with how to repeatedly calculate your square numbers, you'll probably be fine. Okay, it's just going to always take you longer. If you can spot a square number, it's going to speed up your time in exams, and it's going to speed up everything that you do. Okay, but other than that, These are the square numbers in the blue, and in the pink are the square roots. Okay, right, so moving on from that, let's go take a look at cube numbers and cube roots. Okay, so a cube number comes from the idea of a cube. Okay, so let's say I had a cube here. Okay, I'm going to draw it using these 3 squares at the front. So if I've got 3 squares here, so this is going to be a 3 by 3 cube. Okay, this is my front. And then the cube is what takes us into the 3rd dimension. Okay, so here we go. I'm turning my 3 front squares here into a cube. And I'm going to divide it here and divide it here. That line there isn't the best, but it's okay. It gives the idea. So what we've got here is we have got a 3 by 3 cube. Let me draw all the lines in. And I don't know if you remember from some of the earlier tutorials about how we find the volume of a cube, but the volume of a cube is done by multiplying the side length by itself again, and by itself again. Okay, so here, say we've got, so this, the volume of the cube equals side length, and then I'm actually just going to use the symbol cubed, because we should know that that little 3 there means multiply itself by itself by itself. So let's say with this cube that we've got, this is 3 centimeters, this is 3 centimeters, and this is 3 centimeters. What we can see is if we do the 3 by 3, we get the 9 squares at the top. So that's the square number, the 9 is. Okay, so 3 by 3 gets us the 9. But then if we turn this into cubes and we think about the rows of cubes that we've got, when we times the 3 by the 3 for the 3rd time, we get all of these rows of cubes. So we get the 9 cubes here, then we get 9 cubes again, and then we get the 9 cubes again one last time. Okay, so that's why it's a cube number. So 3 cubed equals 3 times 3 times 3. So 3 cubed equals 27, which is the number of cubes you get in a cube with the side length 3. So in this situation, the 3 here, and let me pick a different colour. Okay, so this 3 here is the cube root, and the 7, the 27 even, here that I've coloured in grey is the cube number. So this here is the cube number, and this is the cube root. Okay, and it's all to do with the volume of a cube. Okay, square numbers are all to do with the area of a square. Cube numbers are all to do with the volume of a cube. Okay, so let's work out the cube numbers that we need to know. We don't need to know as many cube numbers as we do square numbers, but there's a few that we need to know off by heart. So the first cube number, well, comes from 1 cubed. Okay, so 1 cubed gives us 1 times 1 times 1, which gives us 1. Okay, so 1 is a cube number and a square number. Okay, the next cube number comes from 2 cubed, which gives us 2 times 2 times 2, which gives us 8. Okay, so I'll highlight these in our grey because these are the cube numbers. Our third cube number is what we've just been talking about, 27, and that's come from 3 cubed, and that's come from 3 times 3 times 3 equals 27. Now our fourth cube number that we need to know is 4 cubed, and that is from 4 times 4 times 4. Now 4 times 4 is 16, and 16 times 4 is 64. Okay, so here we go. That's our fourth cube number. Now our fifth cube number that we need to know is 5 cubed, which is obviously from 5 times 5 times 5. which will give us 125. So that's our 5th cube number here. And then the 6th cube number that we need to know is actually coming from 10 cubed, okay? And that is 10 times 10 times 10, which is 1000. So here we go. These are the cube numbers that you can be called upon in the non-calculator paper, and that they might just expect you to know. So it's worthwhile taking a look at these, and let's get the blue here just to highlight the roots. So these are the roots of these numbers, okay? So if I was to look for the cube root of 1, that would be 1. The cube root of 8 would be 8. The cube root of 27 would be 3. The cube root of 64 would be 4. The cube root of 125 is 5. And the cube root of 1000 is 10. So unless a number has a whole value cube root, then it is not a cube number. The cube numbers have to come from specifically cubing a whole number. If we think back to our cube, if these numbers weren't whole numbers, we wouldn't be dealing with whole cubes, okay? So it just gets messy, and so those numbers, they just don't get in the cube number club, okay? So you only get a cube number from cubing a whole number. Right, okay, let's now move on to our examples. Okay, so here we go. Well, one second, before I go, if you wanted to pause here, just so you can get these things written down. Otherwise, I am now going to move on to our 4 examples to see how we get on with those questions. Okay, so here we go. Example 1 is give a square number between 10 and 20. Okay, so let's think about our square numbers. We had 1 from 1 squared, 4 from 2 squared, 9 from 3 squared, 16 from 4 squared. So here we go, we've got it. We've got a square number between 10 and 20. So our answer for this question is 16. Okay, right. Next example. Example 2. If a large cube is filled with 27 smaller cubes, how many small cubes are along one side? Okay, so this is, remember, 27, you can spot it. It's a cube number. So we need to know the cube root of this cube number. Okay, so the cube root of 27 is 3. So the answer will be 3 small cubes. Okay, great. Right, let's have a look at the next question. So here we go. We've got this example here, which is write down a square number and a cube number which sum to 126. Oh, goodness me. Right, so we're going to have to think about some square numbers and some cube numbers. Okay, now, this is a high number, okay? So I think what we've got to do is we've got to think about the numbers that could take us close to that. So I know that we could have 10 squared, which is 100. Okay, I don't think that's going to work. Because that would need to be 100 add 26. So that's no good because 26 isn't a square number. Well, it's not a cube number even. The cube number that's close to 26 is 27. Okay, let's think about some others. In fact, what I'm going to do is I'm actually just going to write down the square numbers, write down the cube numbers, and I'm going to see if anything pops out. If anything pops out to you before me, then perfect. Otherwise, let's just use a exhaustive method of how to do this. So the square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Okay, the cube numbers that we've got are 1, 8, 27, 64, 125, and 1000. Okay, so these are all the ones that we're meant to know. So write down a square number and a cube number which sum to 126. So the answer is within one of these and one of these. And I think I've spotted it. If you want to have a go and think a bit longer, pause here. But otherwise, I'm just going to give you the answer. And I think the answer is going to be 125 and 1. Okay, because 125, 125, add 1 equals 126. Okay, so we've done it. We've got the square number and the cube number that add to give 126. Right, let's try example question 4, and that will be the end of our tutorial today. So well done if you're still with me, and thank you very much for joining me. So let's have a look at question 4. So if the area of a square is 100 meters squared, how much longer will the side length need to be for its area to increase to 121 meters squared? Okay, right, so that we've got the area of the square, so we've got the square number, we need to know the root. Okay, so the square root of 100 is 10. Okay, and the square root of 121 is 11. Okay, so if 10 by 10 gets us 100 meters squared and 11 by 11 gets us 121 meters squared, the side needs to be 1 meter longer. 1 meter longer for area to be 121. Oh, not centimeters. Okay, there we go. And that is the final question of this. If you have enjoyed this tutorial and if you want some more practice on this, I have also got a video which covers 20 questions and answers all on this topic. So I will leave that for you in the link, and it'll probably come up on the home screen after anyway. But other than that, thank you very much for joining me, and see you soon. Bye.